Hi guys, today I'll explain Kubernetes architecture in simple way, maybe with couple of diagrams. So what is Kubernetes? Kubernetes is a open source system for managing containerized applications across multiple hosts, providing basic mechanism for deployment, maintenance, and scaling up of applications. This statement tells about the Kubernetes. This is I copied from the kubernetes.io. And so a little bit background. So Kubernetes earlier developed at Google. So Google using a very complex than Kubernetes called system called Borg. So uh, it's entitled to it's Google, and Kubernetes is designed for containers. And Google open sourced this Kubernetes in 2014. Various companies supporting in open source community. That's his little bit background and why we need container orchestration engine or management engine. So Docker I solve the problem of packing, deploying, and running applications, and it's good for managing few containers in a single machine or couple of machines. But it's a problem with production applications with hundreds of containers running on a lot of machines. So there is one problem, and people are treating the data center as a computer, so they want to control from single place or view the entire cluster from a single system. Uh, so that is a kind of requirement. Manage the life cycle of the applications in production. So like deploying an application and upgrading to new versions and deleting old versions or canary deployments, uh, those kind of uh, features needed for cloud solutions. And intelligently distribute the applications across the cluster, and uh, because of that you can achieve higher levels of utilization and efficiency. So these kind of problems and requirements are there in cloud, and uh, these tools are coming up, still growing very fastly, like Docker Swarm, Kubernetes, Mesos, DCOS. So, and coming to Kubernetes, it provides a unified way of deploying applications, whether it is a web application or batch job or cron job or any kind of stateful application like databases. And it very good thing about the Kubernetes is a declarative approach. We can you can declare your deployments in simple files like JSON or YAML, and submit to a Kubernetes cluster. So then cluster will take care create deploying those applications by pulling the images from the registry, Docker container uh, registries actually. So if you see the simple YAML file, so this is the YAML file. Most of the data I'll explain later. So these are like API version v1. This is related to all these are related to actually Kubernetes. So based on these, it controls manages the applications. So only thing about I want to mention here is this is the image. This is a container Docker image, which is stored somewhere in the Docker hub. So Nginx. So when you submit this YAML file to Kubernetes cluster, it will pull the Nginx Docker image and runs on container port 80. So this is simple explanation about the YAML. And Kubernetes provides scalability, and you can scale manually, like by issuing some commands or just API calls, or automatically it can the applications can scale based on the CPU utilization or memory utilizations, or you can create custom auto scaling rules. uh, Coming to availability, so at any given point of time, your desired state will be Kubernetes will ensure your desired state of your cluster or application. So it also provides security. So security means accessing Kubernetes APIs. Kubernetes provides APIs to manage your cluster actually, and it's also portable, which can run any private cloud or public cloud or bare metal or laptop with a consistent behavior. This is important actually, consistent behavior. Coming to Kubernetes architecture, this is very high level components involved here. So this is the Kubernetes master, which is sole responsibility of um, controlling the your cluster. These are nodes. Here, in the nodes, your application will be running wrapped as a pod. Actually, I'll explain later that pod. So these are called nodes. Actually, earlier it used to call these are used to call minions. So this is the Docker registry, whether it's a Docker Robo or your private Docker registry. Um, yeah, that's it there. And coming to API. So as I said, Kubernetes exposes the REST APIs to control your cluster. So on top of API, Kubernetes also provides UI and client on the kube control or UI. So users can use either a quick kube control or UI, or if it is a CI/CD, people can develop their own orchestration using Jenkins or some other CI tools. That layer comes here, or if you have time, or if you want to manage your application from your mobile app, you can develop your mobile app and by accessing these APIs. There are multiple solutions can be provided using these APIs. Those are like your own interest. Those APIs, those clients. This is eye level component diagram. And coming to masternode, so this is the masternode. I explained a little bit here more about the masternode. So masternode contains XD. This is a key value pair database which is open source by CoreOS, and this entire state is stored here actually. So why these guys choose the XD is it's a very high performant key value pair distributed database actually this is. And coming to API server, so this is kind of it exposes REST API kind of REST APIs, and it's like a gateway to gateway between a client and internal components. And the responsibility of this API server is accept the user submitted deployment descriptors and validate them and store in XD. And that's the main responsibility of the API server. Coming to scheduler, a scheduler is a component uh, it's which sorry, responsible for choosing a node and scheduling your application as a pod. Um, that is main responsibility. And controller's piece is a very essential important role, and it's kind of business unit sits here. So as I said earlier, scalability, availability, all those things managed by this controller thing. So this is eye level on masternode. Coming to a node, so this is the node. I'm explaining here a little bit more. So node contains mainly Docker, kubelet, uh, kubeproxy, and it comes with Fluentd as a logging framework. So kubelet is responsible for uh, pods executing the executing and maintaining the pods, and reporting back the node's overall performance to a master node, especially to API server. And Docker is responsible for running the containers inside your pods. Pods contains containers, one or more containers actually. And kubeproxy is a network responsible for networking in node. And Uh, I'll explain a little bit about this queue proxy. So, for example, in your one of the pod running a application, one node application, which you want, which it wants to call some other API or some other service or some other database. So here we in that application you just mention the variable of that service. So uh, that variable is mapped to some address here. So and it calls that service. So that is where the high level service discovery happens in Kubernetes. So discovery comes by freely in Kubernetes. So uh, that's about node, and let's go to setup. So all these are good actually. So how we can set up uh, so as explained, it runs on various uh, platforms, right? So this is the Kubernetes documentation and setup. I mean, they nicely segregated the documentation. Uh, so this is the important link. So it's tells about how you want to pick your solution of this solution. So if you're running a local machine, you can have these kind of setups: Minikube, Cube, Cube admin DND, that is Docker in Docker. Various solutions are there, and all these are open solutions. And if you want to hosted solutions, so there are a lot of hosted solutions are there, like Amazon EKS, Kubernetes GCE, Azure AKS. So those a lot of things, platform 9, OpenShift, and IBM Cloud Container Service. So a lot of things are there. Uh, so for example, I'll search for Amazon EKS. So this is the page for, I mean, the introduction page for this. Uh, so if you see the how it works, so if you have if you opted for Amazon EKS, so all these what I explained here, all this setup is done by this Amazon EKS. You no need to run, no need to set up anything. Just use by connecting to AKS cluster with just APIs or uh, uh, kube controller client. Actually, let me search some more thing here. So how it works actually. Amazon EKS. So here, create a Amazon EKS cluster. Just launch your worker nodes. Worker nodes are, I said here, these are the worker nodes, and these nodes require some software, right? So kubelet, Docker, kubeproxy, those will be installed as part of cloud formation. Uh, and then you can configure kubelet or API or whatever way you want to interact with your Kubernetes cluster in AKS. Uh, where am I picking your solution? So this is the Oster solution, one of the Oster solution. And if you go to on-premise, also you can on-premise also you can set up this Kubernetes cluster custom solutions. There are a lot of solutions actually. So set up uh, your Amazon, not Amazon, Kubernetes cluster. So if you go here, these are the table of solutions. There are a lot of solutions are there actually. Uh, that's it for this video, and I'll explain a bit more about pods, replication controllers, replica sets, and all building blocks of Kubernetes clustering using a demos.